All right, we're in 4.7 part 2, area of oblique triangles. So I know I mentioned it in the law of cosines part of the part 1 video, but in an oblique triangle, to get the height, you have to sketch it perpendicular to one of the three sides. So if we're going to call this the height, that means that this is the base of the triangle. And we know that the area of a triangle is 1/2 base times height. Now, I'm going to label this triangle A, B, C. Makes it a little easier because this will be side B, which we're calling the base. This will be side C and side A. And then we'll just call this, we'll just leave it as height. Now, that's the formula if you have a right triangle, okay, using the right angle there. Now the thing is, with the law of sine area formula, you can use this when you know side, angle, side as your three given pieces. Now the way this works is that height that we drew breaks this triangle into two right triangles. So if we look at this, we'll use angle A. From angle A, in this right triangle that's created here on the left, the height would be the opposite side. Side C would be opposite the right angle, so that would be your hypotenuse. And this portion of side B, just to the height right here, would be the adjacent side. Now, in right triangle trig, doing this, you remember that sine of an angle is opposite over hypotenuse. So we can write that the area is 1/2, and then instead of base, I'm going to do some highlighting here so y'all follow this. I'm replacing base here with actual side B of the triangle. Okay, so that's still actually going to be a B. And then instead of height, right here, this entire side, height, I find it using right triangle trig. So if I'm looking for this height, and I knew angle A right here, it would be opposite over hypotenuse. It would be the height over the hypotenuse, which is side C. Now I can rewrite that. To solve for the height, I would have to just multiply the C to the other side. So C times sine of angle A. So if you're missing the height value, you can use right triangle trig and say that the height of this triangle is this side length times sine of this angle. So I'm going to replace that height right here with C sine of A. So I substituted that in for height. And again, this stands for base and height. All right, now this doesn't only work for angle A using sides B and C. This triangle could have been rearranged any which way. So it works for using all three angles. So it would also be true if the sides that we used were A and C, then the angle would be B. And it would also hold true if the sides that we used were A and B, and the angle C. So all three of these are formulas using law of sine area formula. So you've got three different versions of it. Now another formula, we said this one is used when you know side, angle, side. Heron's formula is one that you can use when you know side, side, side. Because you wouldn't know an angle to be able to do this sine of angle A. If you don't know one of the angles, you can't use these formulas. So if you know side, 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 you can use the area formula, square root of S times S minus A times S minus B times S minus C. Now, the lowercase a, b, and c there correspond to the side lengths of the triangle. Okay, you know lowercase a, b, and c. The S variable is the semi-perimeter. We know perimeter is all the way around a triangle or any figure. The semi-perimeter is half the perimeter. So to find your S, if you know all three sides, you would add them all together and divide by 2. So let's give that a shot. Let's do an example using Heron's formula and using law of sines area formula. So in this first example, it says find the area of triangle ABC. I'm going to sketch a triangle first. Start up here. This will be side A, side C, and side B. And the given information is that side A is 5, side C is 6, and angle B is 112 degrees. So what I am given here is side, angle, side. So I know that I can use this law of sine area formula. So the formula is 1/2, and then you have to decide which two side lengths and angle am I using? Well, the given ones. So the side lengths that I know are A and C, and the angle that I know is B. So that's going to be 1/2 5 times 6 times sine of 112. You can do that all at once in your calculator. I'm going to use 0.5 for my 1/2 times 5 times 6 sine of 112. And you would still have to be in degree mode since these angles are being given to you in degrees. So the area of this triangle is approximately 13.91. And again, we're not given the units, but remember when you're finding area, whatever the units were, they would be square units. So just keep that in mind. And again, we used law of sines area formula because we were given side, angle, side. Now, in the second example, I'm going to sketch a triangle again. Actually, you don't even have to sketch it because you can see what you're given are all three sides. So I know I'm given side, 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 so I know I'm going to use Heron's formula. So you don't even need a picture. I'm just going to jump straight into the formula, which says area is the square root S minus A, S minus B, S minus C. So I'm going to find S first. which remember is adding all three sides to get the perimeter and dividing by 2, because it's the semi-perimeter. So 4, 6, and 7 all divided by 2. That comes out to 8.5. So now in the formula, we've got the square root 8.5 times 8.5 minus a, which is 4, times 8.5 minus b, which is 6, times 8.5 minus c, which is 7. Okay, so you do those calculations. You can calculate each difference and then multiply them all. You can type it just like this in your calculator. You can do it in however many pieces that you want to do it in. But what this comes out to in your calculator is approximately, if we go to the hundredths, 11.98. And again, it's square units, but remember the other way you could write that? You could write your units and then put a power of 2 to show that they're square units. And those are your two formulas, depending on what you're given, that you use to find the area of oblique triangles.